to start off by talking about what you need to do as far as U.S. Army Corps of Engineers goes. They regulate anything that goes in a flowing stream, and this goes back to the Clean Water Act in the 70s, I believe, and it's all about wetland preservation. Before you put anything in a stream, you should contact your local Army Corps of Engineers office for a jurisdictional determination. I did this through a permit that I was seeking to put in some culverts. That shows our property and where we're putting in some culverts, and attached this Beaver Dam Waterwheel project to that. And this just shows some of the images that I sent with my permit application, showing basically what we were going to do. We were going to minimize impact on the stream bed by just supporting everything on two T-posts like this, just metal fence posts. And it actually worked quite well. This is where the general layout of the generator and water wheel were going to go in the Beaver Dam. A lot of stuff here now. We cleaned out some of that so we could put the water wheel in there, but basically you got the two T-posts here and the water wheel would be in here. Generator's really not there, it's kind of to the side. This would be where the spillway would be. But the issues, what you need to look at here in your particular situation is how much of a vertical drop you have between where your spillway would be and the level of the water down below, because you don't want your water wheel in the water down there. It's just, drag it down, slow it down. You want it above it, and your vertical drop determines how much or how big of a water wheel you can put in, how much power you can generate. That'll combined with the amount of water flowing. In my case, I really didn't have much water, and I really didn't have much vertical drop here. So, but it did work, and I was able to do it. This shows basically the idea here. This just representing the Beaver Dam and a homemade water wheel turning the spillway. I did put a threaded pipe flange in it so I could have a way to stop the water. So that's basically how I got started on this. And in these pictures here, I'm showing what the Beaver Dam originally looked like. Just a big mess. It'd been there forever. And this is what it looked like with a little bit of the brush cleaned out and the spillway pipe getting ready to install it. And this is what it looked like with the spillway pipe installed and the T-posts in place, getting ready to install a water wheel. And this is a little bit better view of it here. And so now what I did is, I don't like doing anything just like everybody else. I like to do things differently. So I had this idea of taking aluminum flashing just to kind of use on roofing a house and siding and so forth, and cut it into the right shape where I could make these funnel-like pieces here, where I riveted them together with aluminum rivets, no hole at the bottom so it would capture the water, and I took those and bolted them around the water wheel, around a bicycle rim. This shows you what it looked like. This particular one was not the bicycle rim. I also used one, but this was a cartwheel that I bought from Northern Tool. One thing you'll have to do, since you don't want the wheel spinning freely on the axis, you want to turn the axis, is drill a hole through here and pin the wheel to the axis you're going to use, and that it works well. I believe this was particular situation with about 5/8 inch diameter here, and I drilled it. Just was able to take a long drill bit and drill through kind of at an angle from the side and get that in there, and that worked well. This is another view of it here, and this shows the bolts here. I used stainless for as much as I could to keep it from corroding, and where it couldn't, I tried to use galvanized. This is go-kart bearings. I think I bought them from Northern Tool, and they really worked quite well. I didn't have any issues with them. They're like a sealed bearing that permanently lubricated. And this is what it looked like in finished form. And my other video, I show it running. I'm not going to in this case, but these are some pictures here of just showing what it looked like running. And I'll get into some more of this later. But I did have a problem with it getting torn up in the weather. Let me scroll down here real quick, show you what happened. This shows how it just came to pieces when ice got on it. Definitely not rugged enough for ice. I think this would have worked quite well if I just used a heavier duty metal instead of aluminum flashing, use a stainless type flashing. And this is another design that I came up with, where I just took galvanized buckets and bolted them to a wheel. And when the aluminum flashing wheel fell apart, this worked, but there were some issues with it. The problem you have is when the buckets come around, hit your water stream, the top part of the bucket hits the water, splashes it out of the way, so pretty inefficient. Other thing you got to watch for is the angle which the water hits this. I through some experimentation found out that you're better off having the water come in up high than you are in a more vertical look. It makes a big difference, and I'll try to include that short clip in this. This is was one of my latest ones, and I really like this. If you look, you'll see these bolts here. These are galvanized bolts that I bolted to the rim here, put double nuts out here, and was able to greatly increase the diameter. I think this was about 50 inches. That was the most I could squeeze into the that Beaver Dam location. I also cut the top edge of the buckets off. Eventually, I did coat this wheel with an asphalt roofing material, which helped deaden some of the sound. It can be surprisingly noisy, and also just provided some additional corrosion protection. And this shows another view of it here. Kind of interesting. You can actually be pretty innovative with what you're doing. And let me stop this one here, and we'll add some more later. Okay, we're going to test the difference between water on the top of the wheel and water on the side. Let's let it reach equilibrium. I've got an X marked in one of the buckets. 1001, 1002, 1003, 1001, 1002, 1003, 1000, a little over 3 seconds. All right. Try putting the hose in over here. I'm about the same height, but more vertical location on the side. 1001, 1002, 1003, 1004, 1000, almost 5 seconds. Definitely does not work as well. Now the other issue is the kind of generator to use. You can see here I've got this set up with this is a standard automobile alternator. I think a Chevy, a Delco model, I don't remember exactly which one, but I had read that it's impossible to use it for this because they have to turn so fast that you can't get the RPM out of a water wheel, or for a wind generator for that matter. I didn't believe it, so I decided to try it myself. Sure enough, it's an issue to try and get the gearing such that you can get the speed up to generate anything. You're just you're not likely to be able to use it. Time it takes, but I did try it, and you can generate power with it, but the load and the torque required to do that is horrendous. So I would not recommend that. Now, what I did do was I did a little searching and found out that you can buy permanent magnet alternators. I bought one from this company. This is just their website pulled up here. And I believe I got the DC 540 model. And that's where instead of using an electromagnetic field in the alternator, they put high power permanent magnets in there so you can generate the voltage you need with much lower RPM. That worked great. No problems with that. So that is one way you can accomplish that, and that's what I did. Your part. This is one of my wheels actually operating here. You can see I experimented a little bit with pulley size. Ended up with about a 6-to-1 ratio on this permanent magnet alternator, and down here, this is a little greenhouse that I put up near it. A deep cycle battery. This Intella charge controller. I don't think it's available anymore. I believe I also got that from Wind Blue Power. It worked good because it had a 3-phase input off the alternator and a hybrid input for up to 100 watts of solar, which I took advantage of. Here's my solar panel. I just got it off Amazon. Actually works very well. And that worked great with that Intella charge controller because it took advantage of the sun. Now this is a wheelchair robot I made, and I'm going to make another video on that. Several deep cycle batteries here. These were deep cycle gel type batteries in here. This is what I use to store my energy when I was generating it off the Waterwheel, and no problems with that at all. The other big issue I had, and it's worth talking about, is the best I could do, was getting, occasionally I could get 12 volts coming off the water wheel directly off that generator, but usually it was less than that. And, for a battery, a 12 volt battery to be fully charged, needs to be about 12.6 volts. And if it gets down to 11, you risk damaging your battery. So you got to have enough voltage to charge the battery. You don't want to overcharge it. This charge controller would cut it off if it got up there 14.4. That wasn't the issue. My issue was trying to get enough voltage off of this, even though it was generating voltage, to be able to charge the batteries. So what I did is I couldn't find a 3-phase step-up transformer. I bought these 3 single-phase transformers, I think off Amazon, and experimented with the wiring configurations. There's various ways you can wire these things together, and it took a little messing around with it, but eventually I made it work. And I was able to double like 9 volts off of here up to 18 or higher, and it actually worked. You lose some power because of losses in the transformers and everything. However, it enabled me to charge the batteries, even though there was less actual watts going into the batteries versus not being able to charge them. So it was worth doing. And I think in my other video on the Waterwheels, talked about the hazards of Mother Nature. Really, you look at a solar panel, it just sits there. Other maybe cleaning it every now and then and changing angle a little bit. There's almost no maintenance. A Waterwheel will work you to death with issues, and we had beaver dams that had been there 20 years and they got washed out by all the giant rainstorms we'd had in the last few years. So we're just waiting on another beaver dam to get built. And when that does, I'll probably, go back to doing this. But I was able to prove it out. You can make it work.